Another series question here that kind of has multiple parts. This is from an old test of mine. It says, consider the function f prime, whose Taylor series is defined by the geometric series. Geometric has a ratio with a first term of 1 and a ratio of negative 3x. So let's just start writing here. And hopefully we can make some sense of all this stuff. So let's see. The first term is a sub 1, which is 1, and the ratio is negative 3x. So it says write out the first 4 terms in the general term. So what I'm going to write is 1, and then the next term is going to be this first term right here, multiplied by the ratio. Well, it's 1 times negative 3x. That's minus 3x. And then the next term is going to be this term multiplied by, get this out of the way. All right. Would be this minus 3x multiplied by another minus 3x. So that gives me a plus and then a 9x squared, because that would be minus 3x times minus 3x. The next one is going to be multiply this by minus 3x, and that then becomes negative again, because I'll have a triple negative, I guess. And then 27 is the 9 times the 3. And then the x squared times another x gives me x cubed. And then plus dot, 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 plus. Now I've got to write the general term. That's the first 4 non-zero terms. I'm going to get negative 3x raised to the n. And why is that? Because geometric series is always, this would be 1 times negative 3x to the n. It's always the first term here times the ratio to the n, or sometimes you have an n minus 1, but that doesn't matter too much here. All right, so let's see. Write the first 4. Yeah, I've done part A. All right, let's do part B now. All right, use the ratio test to find the interval of convergence for the series. Okay, so the interval of convergence is, what do? We do the ratio test. L equals the limit as n goes to infinity, absolute value, a sub n plus 1 over a sub n. Well, that's equal to, this right here is our a sub n formula. So what do we get? We get negative 3x to the n over, to the n plus 1 over negative 3x to the n. A lot of times we have to copy dot flip because we have a fraction or whatever when we're doing this, but this thing is just a term. There is no fraction. So just do the n plus 1 version of that divided by the n version of that. Oops. You can always tell when I forget my limit notation because I sneak it in like that. So this is equal to the limit as n goes to infinity, absolute value. All right, how do these cancel? All these cancel with all but that. So what's that give me? Negative 3x, like that. And now, 2 comments. 1, there's no more n's. And 2, there's an absolute value. This is going to be a lot easier if I use that absolute value to get rid of the negative there. So this is just going to be the limit as n goes to infinity of the absolute value of 3x. Well, what is that? That is just the absolute value of 3x because there are no n's left in this formula or equation or whatever. So what comes next? Well, we always say negative. We always want that to be less than 1. That's part of the ratio test, right? So what comes next? Well, if I got the absolute value of something less than 1, then negative 1 is less than that thing. 3x is less than 1. And from here, I need to divide by 3, and I get negative 1/3 less than x less than a positive 1/3. So that is almost the end of the interval of convergence. What I need to do now is check the endpoints, okay? So just so you can see it, we said earlier that this was our a sub n formula. So it's sigma. I'm just going to write to infinity I'm not going to write the starting index value because in this case it's actually n equals 0, but I don't want to get into that too much. You might see that. But sigma to infinity of negative 3x to the n. And I need to check the endpoints. So what I'm going to do is plug in this for x and then this for x, and I need to check to see what happens. So x equals a negative 1/3. Well, that gives me sigma to infinity of negative 3 times negative 1/3 to the n. And this is weird because it just simplifies to a negative 3 times negative 1/3. Well, that's just sigma to infinity of 1 to the n, which is just sigma to infinity of 1, which would be 1 plus 1 plus 1 plus 1 plus 1. What does it do? It diverges by nth term. So we are not going to include this negative 1/3 in that interval. And now I need to check. So that was x equals negative 1/3. I'll also check x equals positive 1/3. That gives me sigma to infinity of negative 3 times 1/3 to the n, like that. And that simplifies to sigma to infinity of negative 1 to the n. Now, what does this do? This alternates, right? It goes plus, minus, but it's just 1, minus 1, plus 1, minus 1, plus 1, minus 1, plus 1. It doesn't converge on anything. It doesn't go out to infinity, but it doesn't go to a single number. So this one diverges by nth term as well, which means that the interval is just this thing right here. You do have to show that it diverges at each of those endpoints, but the final answer is just negative 1/3 less than x less than 1/3. All right, so let's read part B. Use the geometric series formula to find the function for f prime of x. So I'm going to go over to purple to do this one. So I need this info right here because it says use the geometry. I was kind of like giving a little bit of a push here. Use the infinite geometric series formula. So what that says is that s sub infinity is equal to a sub 1 over 1 minus the ratio. You should know that from this class, from previous classes, whatever. But what's a sub 1 for this formula? And what's r? Well, there are these two numbers up here, 1 and minus 3x. So what do we get here? I get 1 for a sub 1 over 1 minus a negative 3x, which simplifies to 1 over 1 plus 3x. And that's actually the function for f prime. So it says use the infinite geometric series to find a formula for the function of f prime of x. This is f prime of x. And that's a trick that I can do whenever we have a geometric series. Lots of other series we can't do that. Next thing, so that's the end of part C. I have lettering issues. The last one, integrate your answer from part A to find a function, f of x. You do not need to solve for the plus c. So I'm going to come down here. F prime, this was C, this was D. F prime is 1 over 1 plus 3x. If I integrate f prime, then that gives me f of x. So that's going to be the integral of 1 over 1 plus 3x, which is ln, absolute value of the bottom. You could use some u sub. I'm just going to do it. 1 plus 3x. And then I need to divide by 1/3 out front to balance the chain rule that we would get for deriving this. Notice if I derive this, I get that back. Plus my c. So let's see if we did what they asked us to do. It says integrate your answer from part A to find a function, f of x. You do not need to solve for the plus c. Yeah, so we're done here. We found the function. We integrated this thing that we got from geometric series formula. And we got 1/3 ln 1 plus 3x plus c. Sometimes I'll have us solve for the plus c, but for this one, that's all you need to do. See you in the next one.